Hi class, thanks for tuning in for your next E lesson. Our topic today is going to be something called the change of base formula, and we're going to use that to solve some exponential equations. So we have two learning targets. The first is I can use the change of base formula to evaluate logs, and then I can solve exponential equations. And we're going to do that we're going to review how to solve by getting the bases to be the same, and then I'm also going to introduce a new method where we change our exponential equation into log form. So to introduce the change of base formula, we're going to evaluate 3 logs kind of by hand, just using some mental math, and then we're going to try to evaluate those same logs using a calculator. Okay, so if I ask you to evaluate log base 2 of 16, okay, we start by kind of putting a box here. We're trying to find what this log equals. Okay, and so we know the base is 2 and logs equal exponents. So we're trying to figure out 2 to what power equals 16. Okay, so we know 2 to the 4th is 16, and so this log equals 4. So for the next one, we put a box here, and we're trying to figure out 6 to what power equals 36. And we know that 6 squared is 36, and so this log equals 2. And then the last one, if we want to evaluate the log, we've got to figure out 3 to what power equals 1 over 27. We know 3 to the 3rd is 27, so 3 to the negative 3rd is going to equal 1 over 27. And so this log equals negative 3. Okay, so in part B, it says use your calculator to evaluate the expression in part B. So we have a limitation on the calculators. We can do a log in the calculator only if the base is 10 or if the base is E. So if you look above the on button, you'll see that there's an ln button and there's a log button. Okay, the problem with the log button is if you press it, you cannot specify your base. Okay, so your calculator only does common logs and natural logs. Okay, we're not going to talk about natural logs for the purpose of this course and the e-learning. We're just going to focus on common logs. Okay, so the only button that we have here on the calculator to help us with logs is the common log, assuming the base is 10. Okay, so we're going to take log base 2 of 16. That was our question for part A. And now for part B, 1B, it says to divide log of 16. So hit the log button and then type in 16, close the parentheses, and then divide that by the common log of 2. And what you're going to notice if you hit enter is that you get the same answer that you got in part A. So log base 2 of 16 is equal to log of 16 divided by log of 2. Notice 16 is the argument, 2 is the base. So it's kind of a workaround. It's a way to specify the base, to use your calculator to evaluate a log that does not have a base of 10. So let's look at 2. So we know that log base 6 of 36 equals 2. Well, what if we change that to log of 36 divided by log of 6? So log of argument divided by the log of the base. And notice your calculator tells you the answer is 2. Okay, so what we're finding here is that these expressions here are equivalent. Log base 6 of 36 equals log of 36 divided by log of 6. Okay, and let's try one more. Does this log equal log of 1/27 divided by log of 3? So I'm going to hit the log button. I'm going to grab my fraction key, and I'm going to type 1/27 and then arrow over. So I have log of 1/27. I'm going to divide that by the log of the base, so divided by log of 3. And notice we get negative 3. So it's really a workaround to kind of meet the limitations of the calculator. So if you want to use your calculator to evaluate a log, then you use what's called the change of base formula. Okay, so here's how it looks with variables. So if you have log base b of a, that is equal to the log of a, log of the argument, and then I'm going to put parentheses around this because the calculator kind of forces you to use parentheses, divided by the log of the base. Okay? And oftentimes when we use a calculator to do the change of base formula, your answer will be a decimal because otherwise we could just do the log using mental math. So let's try some of these problems. So the first example says use the change of base formula and your calculator to evaluate each log. Round to the nearest thousand. So that's going to be 3 numbers past the decimal place. All right, so for the first problem, we're going to do log of the argument. So log of 1 over 128 divided by log of the base, log of 2. And the only reason I'm using parentheses around the argument is because when you hit the log button on the calculator, it automatically opens parentheses. Okay, so I'm going to do log of 1 over 128, and then arrow to the right, close your parentheses, and then divide by log of 2. And this one, we just get -7, so we don't have to round that. Okay, it makes sense that your answer is negative because you started with a base of 2, and now you have 1 over 128. Okay, so the next problem, we're going to do log of the argument. So log of 84, close the parentheses, and then divide that by log of 7. Okay, so in the calculator, we have log of 84 divided by log of 7. And the answer is 2.277. Okay, so if we round that to 3 decimals, that 9 bumps the 6 up to a 7. So go ahead and pause the video and try the next 2 problems. And then I'm going to go through them quickly so you can check your answers. Okay, so if you got 2.796 and -6, then you're in good shape. So that's called the change of base formula. Okay, so now we're going to move on in the lesson to solving exponential equations. Okay, and we're going to start by reviewing some problems that we talked about in the first week of e-learning. And that was when we have an exponential equation, and we are capable of writing each side with the same base. Okay, so a reminder, we're going to solve each of these problems by rewriting each side to have the same base. So 2 to the 4x equals 32 to the x minus 1. Okay, so we can rewrite 32 as a base of 2. So we know that 2 to the 5th equals 32. And so we're going to write 2 to the 4x equals 2 to the 5th. And then we have to still raise the 32, or the 2 to the 5th, to the x minus 1 power. And so we're going to multiply. A power to a power means multiply. So I'm going to multiply my new exponent 5 with my existing exponent, which is x minus 1. Okay, now that I have the same base, I can set my exponents equal to each other. I'm going to distribute the 5 to get 5x minus 5. And then here I'm going to subtract 5x from both sides. -1x equals -5, and so x equals +5. Okay, so for the next one, I can rewrite both of the sides with a base of 9, so I don't have to do anything to the left side. I'm going to rewrite the right side of the equation. I know that 9 squared equals 81, so I'm going to make the 81 9 squared. And then I'm going to raise my new exponent to my old exponent, 3x minus 2. Power to a power means multiply. Now that I have the same base, I'm going to set my exponents equal to each other. Okay, and then I'm going to subtract 6x here. This time I have -4x equals -4, and so x equals +1. Okay, so those are a review from week 1 of e-learning. Okay, so now we're going to talk about what happens if we have an exponential equation and we are not able to rewrite both sides with the same base. Okay, so for example, 4 to the x equals 15. We cannot write 15 with a base of 4. We also cannot write 15 with a base of 2. Okay, so this is the new type of problem. So sometimes we cannot rewrite each side with the same base. And so what we're going to do instead is we are going to rewrite the equation in log form, and then we're going to be able to use the change of base formula to solve. Okay, so rewrite, always try to write each side with the same base. If that's not possible, then you're going to solve by using a log. All right, so we're going to change this to log form. So we're going to write log base 4 of 15 equals x. Kind of an easy way to remember that is if you make like a little E shape, a little hook, the 4 goes first, that's the base, and then the 15, and then the exponent is last. Remember, logs equal exponents. So now we have log base 4 of 15 equals x, so all we have to do now is use the change of base formula. To evaluate this, we can do log of 15 divided by log of 4 in the calculators, and that is going to equal x. And so we just have to type log of 15 divided by log of 4. Okay, so this first one, we get x equals 1.953. It says round to the nearest thousandth. Okay, so if you feel stuck, you're trying to solve an exponential equation and you feel stuck, change it to log form. Okay, so let's try another one. So remember, start 1, 2, 3. You make a little hook. 1, 2, 3. And so what that means, we're going to write log base 7 of 11 equals x. The base we know goes in the basement of the log. If you can remember that logs equal exponents, then that 11 ends up being the argument. Okay, so now we can use the change of base. We can evaluate this by doing log of 11 divided by log of 7 in our calculators. Move that up a little bit. Okay, so log 11 divided by log 7, and x equals 1.232. Okay? All right, let's bump it up one more notch of difficulty. Let me change color here. All right, so this one, 5 to the x plus 2 equals 22. We cannot write 5 and 22 with the same base. So we're going to change this to log form. Log base 5 of 22, 1, 2, 3, equals x plus 2. Now I'm not going to do anything with the x plus 2 yet. I'm going to evaluate the left side using the change of base formula. Log of 22 divided by log of 5 equals x plus 2. So I'm going to use my calculator to evaluate log of 22 divided by log of 5. And then I'm going to round that to the nearest thousandth. 1.921 equals x plus 2. The last step is to subtract 2 from both sides. And you get x equals negative 0.079. Okay, so if your exponent has some operation in it, then you save that for last. All right, and then the last problem. Now, before we change this to log form, we have to get the base of 4 by itself. So we're going to start by dividing both sides by 5, and we get 4 to the 3x equals 10. Now, we're going to change it to log form. So log base 4 of 10 equals 3x. 1, 2, 3. Okay, you can kind of make like an E. So now I'm going to evaluate the left side using the change of base formula. Log 10 divided by log 4 equals 3x. So log of 10 divided by log of 4 equals, okay, I get 1.661, and that equals 3x. So the last step is to divide both sides by 3, and your answer is 0.554. Okay, so hopefully that lesson made some sense. I want you to go ahead and complete the assignment, the day 15 assignment posted in Schoology, and you're going to submit that, and I'll give you some feedback. Thanks for watching, and I'll talk to you tomorrow.